Welcome back to the Punny Math Teacher. So today's expectations are the same as always. Make sure you're taking your time, pause, rewatch, and the pausing is very helpful, especially with polynomials when we write big examples. Today has one of those. So if you want to pause and just take your time and write, that's what it's for. Please do that. I know I talk really fast. You can also change the playback speed. All right. Unit objectives. So remember, these are a whole unit altogether. So to name polynomials, we've completed. We've also added and subtracted. And today we're doing multiplying. I should actually make this, multiplying monomials and polynomials. So we're actually going to break this into two sets of notes. The first one is today's multiplying a polynomial by a monomial. And the second one is going to be just plain old multiplying polynomials together, no matter how many terms they have. Remember that a monomial has one term, and then in this situation for this notes and the next one, polynomial is in general anything with more than one term. Okay, so just know that that is a thing, but naming it specifically, I can be more specific if I call it a binomial or a trinomial. And typically with the multiplying polynomials, it's typically meaning binomials and trinomials because we're going to stick with 2 and 3, but we will get a little bit longer in our polynomials. So let's go to our table of contents. So we have finished 40 and 41. We are now on 42, multiplying polynomials by monomials. And note that we are moving into polynomials in general on page 43 next. So let's get the 42, 42, 42. There we go. Okay. So there are two different ways of doing this, and I'm going to show you 4 examples. So this is our graphic organizer. We're going to start with the steps in the middle, and we're going to do 4 different examples. These 2 will be method 1. These 2 will be method 2. A simple, short, and sweet, and then a little more complicated and putting more terms in there. So just an FYI, that's where we're headed. That's why I'm starting in the middle. So even though it looks funky, we're going to start with the circle in the dead center of our paper. And these are the steps that we are going to follow. 1 is to distribute to every term. And that is a really common mistake. So even if it seemed like on the subtraction one, you're like, really, no one in the world doesn't keep going with their distribution. It's pretty often. People see that negative, they do it once, forget about the parentheses, and they're done. They're not really done though, but make sure that you are distributing to every single term, and then after that, we're going to combine like terms. Remember, like terms mean same variable and same exponent. If they don't have those, they are not like terms. So we're now going to come up here in this quadrant 2 location, and we're going to use the area model method. So everything on this left half of our page will be following the area model. It could also be called the bar model, but area I think is the most common way of pronouncing it or calling it, defining it. So 2y cubed multiplied by 4y squared. All right, so the area model, if we remember, area of a rectangle is length multiplied by width, right? You've seen that from elementary school, middle school, all right? So we're going to build a rectangle. Now this rectangle has specific dimensions. It has 2y cubed as one of the dimensions and has 4y squared as the other dimension. So if I want the area in between, that is the product of these two monomials, because this is one term, this is one term. So I'm going to multiply those two monomials together. So I'm going to do 2 multiplied by 4. That gives me 8. Y cubed times y squared. Remember, we already had our exponents unit, and that's why we had it, was so that you could remember the expanded form that if I have y times y times y, so that's y cubed, and then I multiply by 2 more y's, how many y's is that total? 5. So this is 8y to the 5th, and what's convenient about this area model with monomials is your answer's already boxed. Ta-da! And that's it, okay? So the area model is physically writing your answers, your terms, or your monomials or polynomials outside of the area that you are finding, and then multiplying to get the inside area, all right? So then example 2, I call it the rainbow method just because that's what I call them, and they help me remember to distribute everywhere, but you don't have to do that. It's not called rainbows. People call it rockets. People call it shooting the moon. I don't know what you want to call it. Drawing arrows, but they help me, and note that I'm drawing them as I'm doing it. I don't just draw them for the fun of it. It is a problem-solving tool for me. If it doesn't help you, don't do it. If it helps you, do it, all right? So, for example 2, this is another monomial, 5ab cubed c times negative 3abc. So notice the exponent on a is a 1, because we don't see it, it has to be a 1. B is a 3, C's exponent's a 1, A, B, and C all have exponents of 1 as well. If you want to go back through and write those ones down so you actually see them, please do. If it doesn't help you, don't do it. If it helps you, do it. All right, so I'm going to draw rainbows just because it's going to help me do the coefficients first, and then I'm going to do each variable after that. So coefficients first. So 5 multiplied by negative 3 gets me negative 15. Now a to the first times another a gets me a squared. B cubed times b to the first is b to the fourth, because that's 4 b's all being multiplied together, and then I'll go under so I have room, and then I have c squared. This is my final answer. Okay? If it helps you, call them rainbows, call them arrows, or just call them, I'm doing it one step at a time. I'm going coefficients, then I'm doing each variable, all right? So I'm going to write those steps down here as well. So I did coefficients first, and I multiplied those. All right, so I multiplied the 5 by the negative 3. Then I'm doing the variables with their exponents, but I added their exponents because I have an a multiplied by another a. That means there are 2 a's being multiplied, so it is a squared. All right, so think about that and why it all worked. Pause, go back to your exponents booklet, which is on page 19. So go back to page 19. All right, so I'm going to draw a little arrow up there. We're going to come back down here. There's my arrows before my orange runs out. So again, I'm going to use the area model. This is example 3, so it's a lot larger of an example. We just did a monomial multiplied by a monomial. Oh, it's been down there the whole time. Now we're going to do a monomial actually by a polynomial that has multiple terms after it. So we're going to have negative 2ab squared multiplied by 3a cubed b minus 2a squared b plus 4b squared. And then just for the sake of size, I am going to write example 4 at the same time, just so that you know how it's all going to lay out. 3x squared times 5x to the 6 plus 4x squared. I purposely made that one shorter because the rainbow method's not that much different than it was originally on the monomial by monomial, and this way, no matter how big your handwriting is, it should all fit on one line. That's the goal. So for the area model, we do have to again draw a rectangle. And now because I have 3 terms inside, this is actually a quartic trinomial because the total degree up here is 4. Random thing. Okay, so this is a trinomial, which means I need 3 lengths, because while this length is negative 2ab squared, the width, or I guess I called this the width and this is the length. So the width of the rectangle is negative 2ab squared, but the length of the rectangle is made up of 3a cubed b plus another negative 2a squared b plus a 4b squared. All right, so I'm adding each of these bits of length, those distances together to get the total length. All right, if it helps, you can always think of this as addition of a negative. And now I need to find the area of each individual part of my large rectangle. So I'm going to multiply them. 3 times negative 2 is a negative 6. I have a to the 4th and b cubed. All right, pause. Look at that. How did I do it? I want you to figure out and tell yourself out loud, like scream to the top of the lungs, like, this is what she did. She multiplied blah, blah, blah. She added blah, blah, blah. Okay? Pause the video. Go do that. Glad you're back. All right, and I want you to go try the 2 and the 3. Try these other 2 openings, okay? Pause. Go do that. Did you really go do that? You better go do that. I hope you're done. Okay. I feel like Dora, kind of. Dora, the movie, was awesome. Just FYI. Okay. And yes, I watched that, and I am really old, but it's all good. Okay. So, we have all three of these terms, but are they like terms? Let's look. They both have A, B, A, B, A, B. Okay, they all have the same variables. Now, do they all have the same exponents on those variables? Does another of these terms have 4 A's? No do. Okay, so they're not like terms. And these have 3 A's. Nope, none of them. Okay, so these are not like terms. That means my final answer, which this is my largest exponent, has a degree of 7 altogether, plus a positive 4a cubed b cubed, minus 8ab to the 4th. This is my final answer, all right? It's as simplified as it gets. So that's the area model. For this one, rainbows, again, we're thinking each rainbow, I'm going to be doing the coefficients first, then I'll do the variables. That's what I also did in the area model, coefficients first, and then I work on the variables and exponents. So in this one, I'm going to distribute to this first term. 3 multiplied by 5 gets me 15. I have altogether 8 x's. Can you do the second rainbow? Notice I did the first rainbow, I drew it, then I did it. Now I'm drawing the second rainbow, and now I'm doing it, okay? So I'm not drawing them at the beginning and then ignoring them because they're not helping me. Make sure they help you. This helps me, okay? If it doesn't help, don't do it. If it helps you, do it, all right? Okay, and that's our answer. Though if these don't help you, and they don't do them, great. But find out what does help you. So don't just give up like, oh, nothing's helping me. Well, then go figure out what does. You can actually do it and be successful, all right? And if you have questions, ask your teacher. I'm sure they're going to want to help you and be successful. Okay, so then comprehension questions. So we still think about x-intercepts, naming them. Maybe you have more respect for why we name them because this total list of your notes was multiplying polynomials, that's a vocab word, by monomials, that's a vocab word. We also talked about coefficients, variables, exponents, like terms, distribution, rainbows and area model, depending on what term and vocab method you like. Anything else we talked about? We did a lot of different vocab stuff, so making sure we have common vocabulary is definitely helpful. And why? Why is it helpful? All right. Thank you for watching. Have a great day. And you are awesome.